Alright, in this video we will learn to state the amplitude and the period given a sine or cosine function. Alright, let me just bottom line it for you. If you have a function of the form y equals a sine of bx or y equals a cosine of bx, the amplitude is simply a. But the period is a little more complicated. It's 2 pi divided by the b. Now 2 pi is the usual period of the sine or cosine function. Alright, now I'm using this word period. You understand that, for example, the cosine function is a periodic function, meaning it repeats the same values over and over and over again. Alright, in this case it goes from positive 1 to negative 1, back to positive 1, back to negative 1, over and over again forever. So somewhere in this repetition is the smallest length of the function that you could repeat over and over again to get the whole thing. So that smallest repeating part is called the period. So in the case of sine and cosine, when I say that the period is 2 pi, that means if you look at a length of 2 pi radians of the function, then that's the smallest part of this function that I could then repeat. So you could see this 2 pi, once I go from 0 to 2 pi, that's where it starts over again and repeats for another 2 pi. Alright, so 2 pi is the period. You can see that in the sine function as well. You know, so this part of it, it goes up and then down and then back to the beginning. That's the period. That's 2 pi. Once it does that, then it just repeats. Let's take a quick look at it on the graphing calculator. So here's the parent function y equals sine x. Alright, so you can see it's doing its thing, starting at 0. It's going up to 1, down to negative 1, and then back again. By the way, each one of these marks is pi over 2. So this is pi and this is 2 pi. So you can see the period, one period right here is 2 pi. And then it's repeated again. So let's see what effect it has if I change this and I give it a b value in there. So let's do sine of 2x instead. Let's see what that does. I'm leaving the original function for a comparison. Okay, so by putting that 2 in there, what it's doing, it's causing the function to duplicate itself twice as fast. So you can get twice as many repetitions in the same space. So as a result, look what happens to the period. The period was 2 pi. It had to go all the way from 0 to 2 pi before it started over again. But look what's happening now. So it's starting right here, okay? It's going up, and then it's going down, and then it's going back to the beginning, and then it starts over again right there. So this is now one period of this function, and instead of going all the way to 2 pi, it repeats. It starts repeating at pi. So the period is now pi. It's hard to draw on this version of the screen. The period went from 2 pi to pi. Okay? So that's why we say the period is 2 pi divided by this b value. So looking at the function that we just graphed, the function was y equals 2x. Sorry, the sine of 2x. I'm forgetting a kind of important part here. It was y equals sine of 2x. So according to this little formula, the period should be Alright, I'll use P for period. The period should be 2 pi divided by this B value. So 2 pi divided by 2. And so that would give us that the period would be pi, which is exactly what we saw. So that's what this formula means. Okay, so given an equation, state the amplitude and the period. Well, the amplitude is just going to be the absolute value of this A value that's in the front. So the amplitude is going to equal 2/5. Alright, it's just the absolute value. Now the period is going to take a small amount of calculating. Okay, so the period, remember we have a formula for that. It's 2 pi divided by this B value. So in this case it's 2 pi over 9. Well, yeah, I guess that's really all there is to it. Alright, so the period is 2 pi over 9. Okay, look at number 4. The amplitude is 2/3 because of this right there. Alright, it's just the absolute value of 2/3. Now the period is going to be 2 pi divided by this B value. Alright, so it's 2 pi divided by 3/7. So if you want to divide by a fraction, then you multiply by the reciprocal. So that's 2 pi times 7/3. So that's why the period is going to be 14 pi over 3. Okay, because this is like over 1 and you just multiply straight across. Okay, look at number 5. The amplitude is going to be the absolute value of this. So the amplitude is 2.5. The period. See how I have theta over 5? Think of this as 1/5. Okay, think of it as 1/5 because that's the B value. So the period is going to be 2 pi divided by 1/5. Alright, so that's why the period is going to be 2 pi times 5. I'm multiplying by the reciprocal. So that's why the period is going to be 10 pi. Okay, and number 6. Once again, the amplitude is just this number right here, the absolute value. So the amplitude is 1/3. Again, think of this as 1/3. Alright, 1/3 theta. So that's my B value. So the period is going to be 2 pi divided by the 1/3. So that's 2 pi times 3. That's why the period is going to be 6 pi. Here endeth the lesson.